So again, this morning's topic is going to be covering HTTP. This is like the web protocol. Who's heard of HTTP, just to get started? All right, what is HTTP if you had to say it?
Transfer protocol?
Hypertext transfer protocol, thank you. What else? What does it do?
No, I mean, I've heard.
You've heard of it.
Isn't this like the actual, so like, doesn't JavaScript interact with, oh no, that's HTML. No.
Okay, John. You raised your hand, so.
Did that?
Yes.
I just know what it stood for. No, it's a language to sort of like, it's a way to present data on websites from, they can store it on servers, and then it can go from, make requests up to other servers, and then present it on a browser or something, and
It's not false.
that kind of thing.
And it's HTML.
Hypertext markup language, yeah,
Yeah.
that's true. I give up.
Is it basically the internet where it's the means by which you navigate through the internet?
It's so I think everyone has it like partially correct. I hope like the next couple slides kind of answers it. Answer to your question is kind of. So HTTP is also known as the Web's protocol. It stands for sorry, it's because I didn't click into this. It stands for Hypertext Transfer Protocol, and it's how we basically send requests over the internet and receive responses back and forth. So the internet, when people say hack the internet, it is not actually possible to hack the entire internet, because the internet is made up of a bunch of servers, and the internet is just made up of a bunch of servers where you give a request and then you receive a response. It's very much like interacting with other people on a daily basis. The original protocol was built in 1991, and it has the origins of hypertext specifically go as early as 1930. In 1930, there was a person who wanted to basically create a symposium of all like the greatest poetry, and he called it an encyclopedia for the world. So there was a way that you were supposed to say, I want to push up, not even, it's so hard to go back into like olden times. There's a way to say like, I want to add things to this encyclopedia and for this person to also respond to you, because this person was getting responses from all over the world. That was like the earliest recorded ways of how to pass back and forth hypertext. But in terms of modern day, HTTP protocol, it was meant mostly as a protocol for transmitting hypertext. Hypertext is not really used anymore. What we are doing back and forth today is we're sending HTML back and forth. How do I not read everything on the slide? Yeah, so again, HTTP is the protocol of how we transfer things over the internet securely.
The procedure.
It's like exactly. It's the procedure, the mechanism of how I send information over the internet, from anything from HTML that shows up on the page to CSS to give styling, and we're going to cover all this in 2 days. JavaScript, API responses, images, all that kind of stuff is sent over the HTTP protocol. So the HTTP protocol has two parties involved. You have your client, which is you. Like when you go on Google Chrome or you go on Firefox or something like that, and you say google.com, you are the client. You're making a request, and then Google is listening. So whenever you make that request to Google, it'll hear your request, it's going to acknowledge it, and then it's going to go into the server, grab all the information you need, and send you a request back, send you a response back to your computer. The requests and responses are pretty plain text. We're going to just go into each one and kind of see what's going on here. So on the left-hand side, at the on a very easy level, this is what we have in terms of a request. It says a few things that we've never seen before, and then this is a response. So up here, we have what's called the request line. Request line is made up of 3 different things.
And sorry, where is this? Like,
This is, so whenever you type in, behind the scenes, when you go on google.com, right, and you type in google.com, you hit enter. What's happening behind the scenes is your client, your machine, is making an HTTP request to Google's servers. It's all behind the scenes. You never see this in real life. But if you were to take a look at the quote-unquote logs, which is basically saying like, what's all the traffic that I'm doing? Like you would see every single request you make looks a little something like this. There's actually some more stuff optional, but this is the baseline of what's going to look like. And on the right side, this is like the response that's going to come back. It's all this like HTML head title stuff. This is like what the server is sending back to you, and then your Google Chrome will make it so that it looks a certain way on your computer. What you're used to is Google.com or Amazon. So this is all happening in the background. This is what makes up HTTP. So we have the request line. There are 3 things in every single request line. The first thing is going to be your HTTP method. The second one is going to be your URI. URI, not to be confused with URL. URI is Uniform Resource Identifier. And then the final thing is the protocol version. And we're always on HTTP 1.1 right now. That's just the current protocol that we're at right now. Kind of like if you have an iPhone, you're currently at iOS 11. That's the version that we're currently on. And we've been on this version here for HTTP 1.1 for quite a while now. So
it was 1.0 before.
probably, yeah. I don't know, 0.9. I'm not, yeah, it could be. So the first, inside of an HTTP request, the thing that your computer sends over to google.com, the first line always starts off with this GET request. It's basically saying, this is more or less the address that you're writing on top of the inside of an envelope. Well, I mentioned a little earlier, there's these methods right off the bat. And there's probably, I think, upwards of like 13 to 15 different methods that you can potentially send over. But the big ones are going to be get, post, put, and delete. This head one I haven't really used before. Get is exactly what you think it is. I'm asking you to give me something. So if I say, hey, go get that thing, it's like saying, like, I'm making a GET request to google.com, meaning I just want to retrieve information from google.com. If I'm clicking on, yeah, that's really about it. I'm not pushing any data up. I just say, I just want to make this request. Just give me back some sort of information. That's all a GET request is. A POST request, on the other hand, is basically I'm not getting information. I'm not just requesting information. I'm sending you information. So when you log into a website, you are making a POST request because you're sending information up. When you pay via credit card or something like that, you're posting information because you're sending them stuff. Put request is basically I'm updating something. So I'm not creating something new, but I'm updating to something that already exists. And the last one is called a delete request, which is I want to cancel my account with RCN, or I don't like Sirius Radio or something like that. At that point, I would want to make a delete request. So again, your big ones are get, post, put, and delete. Those are the big 4 that you're going to need to know.
When do you use those?
Whenever you want to make any sort of, so when you make a request over the internet to like, if you just type in google.com or amazon.com and hit enter, that's a GET request saying like, I'm making a request just to give me a bunch of information. The post request is like, if I'm logging in, I'm sending information to your server, or I entered my credit card information, or like I said, like place this order. I'm posting a new resource. I'm changing something on their end.
So I thought you were actually typing in those.
Oh no.
I misunderstood what you said. Okay.
Yeah.
Thanks. What was the put again?
Put is updating something that already exists. So if I have, let's say I have I got married and I changed my last name, or I misentered my birthday, so I need to enter it in again. My record already exists on the server side. I need to update it, so I'll make a put request, and that's how they know it's something that's already existing in their database, so I can update it. And then finally, I don't want to use Amazon.com. I don't like Uber for XYZ. I'm going to delete my account. That you would make a delete request, and these are all like the common verbs of HTTP. This middle section right here is basically is called the Uniform Resource Identifier. It's the URI. So you've seen URLs. URLs is this giant thing over here. A URL actually consists of many different things. And so if we were to break it down, you have the protocol. That's the first little bit right here. You have HTTP and HTTPS. HTTPS stands for secure. HTTP means not secure. And I'm going to show you a little demonstration of this in just a moment. The host is basically where does your website live? Google.com, codeplatoon.org, Amazon.com. That's the host that's hosting all of your all of the pages that you can potentially visit. And then finally, afterwards, this /bio.html or like codeplatoon/apply. That's where the that's the URI, the Uniform Resource Identifier. Once using the HTTP protocol, I'm going to hit this particular host, Amazon.com, and then from there, I want to get this specific resource, bio.html or /apply or something like that. It lives on that particular host.
What did URN stand for?
URN stands for, where's URN? Uniform Resource Name. Okay, thank you. And again, this is just this is conceptually just how the web works. It's a series of requests and responses. It's just I make a request to you, you give me a response back. URI stands for Uniform Resource Identifier. It means like once I make my request to Google.com, Google.com has like 1 billion different pages, or Amazon.com has 1 billion pages, or even codeplatoon.org has like 50 pages or something that you could potentially get to. So it's like saying I'm going to walk into a giant building like across the street at Chase Tower, right? Chase Tower has thousands of offices and like tens of thousands of cubicles probably inside of it. So it's saying like, once I make the request and I get inside the Chase building, where am I supposed to go once I get inside the Chase building? There's many different places I could go, but it's like once I get there, where do you want me to go next?
Can you command line?
What's that? Yes, you can command line stuff. Yeah, it's called using a command called curl, and you're going to do that today if you want to do the challenges.
Okay, I'm sorry, I may have missed this. So like URN and URL. So when I use my browser, right, I don't have to type in HTTP :
You don't,
right? So no. Why is that?
Your browser makes a lot of assumptions. When I go to like chase.com, I don't have to type in HTTPS www.chase.com. It knows there's a common, I'm not sure if this is actually the website, but if this is the actual reasoning, but you visit those sites long enough for your browser to make those assumptions for you and to say like, oh, you were going to chase.com. Chase.com actually lives here at HTTPS www.chase.com. And so I'll fill that in for you. I want to take a quick stop here and kind of show off one thing. So when I go to something like, I don't know, I don't have Wells Fargo, so I feel comfortable going there. So I go to wellsfargo.com. If you take a look on the top left here, there's this little green lock button, right? And it says secure on it. Most modern web browsers have this kind of built in. When I click on this to get a little bit more information, it tells me that this is a secure connection, meaning that when I send my information, I log into Wells Fargo and I give my username and my password, they're going to encrypt both my username and my password over the internet. So from the time I hit this, if someone's listening for traffic, like if someone's just monitoring all the traffic that comes in and out of like level office or something, they won't be able to see my username and my password. Whenever you go to any sort of any site that requires social security, birthday, anything that requires sensitive information, please make sure that it has this HTTPS at the end. That means it's secure. The information that you're passing back and forth is secure. Because the alternative is this. So Level Office has something called their booking thing for basically saying whether or not whether or not I can book a conference room, right? And if you take a look up here, it says not secure, but it's asking me for a username and the email. If I right-click, go to inspect, go to network, and I hit login, okay, where? It's in here somewhere.
Tell me you can see the password.
You can see the password.
Oh shit. It's like, yeah, and people have like same passwords for.
Exactly.
Wow.
I can't find it. Where'd it go? Kara, do you know off the top of your head?
Shouldn't it be in on the booking request at the top? Of the,
That's why they're always.
you can definitely.
Oh, there it
instead
is.
of
You're
text,
correct. Please be here. Where is it? Yeah.
use this.
So let's do
Which one
this.
is there any of those making not a get request?
Let me log out and try it one more time.
So what would somebody have to do to like actually watch that traffic?
It's not
Beyond your network?
just be on your network.
Watershard.
Yeah.
Beyond what network?
So as long as you're on the level office network and you can and you have like some sort of administrative rights, you can actually just watch all the traffic that comes in and out. Or if you're at a coffee shop or something like that, and you're connected to like the Google Starbucks, for instance, I'm pretty sure Google does not do this, but if you had if you had some sort of random like open Wi-Fi kind of thing,
Yeah.
you basically can just connect into the network and watch all the traffic with as simple as a command as, I think it's, I'm not entirely positive. I just know that it's easy.
There's things
Just
called
start.
packet sniffers, for example, or like that gets into larger security stuff.
Yeah.
But the communication you're making between your computer and another computer, those requests and responses, it's public unless you encrypt that information.
Or something or what?
Unless so you can utilize things like that. Now, so the passing of information back and forth is just like you sending a piece of paper back and forth, right? If you want to secure it, it's like putting an envelope in, like putting the paper in an envelope. And you're still passing back and forth that information. It's just, and so people can see that that information is being passed back and forth, right? But you've secured the actual information that you're sending back and forth, and that's the part that's differentiating you between utilizing a full open HTTP interface and HTTPS.
So what does a VPN do in that regard?
This is where that that guy's presentation when we went to DRW was really interesting, because he talked more specifically about like what that's doing in VPN.
Yeah.
I can't explain the specifics. I might be mistaken, but from what I understand, a virtual private network is basically saying like I'm creating what is called I'm creating a network within this larger network. And only allowing creating basically an extra barrier to what I'm doing, so that everything I'm doing is basically going to be in and out of like a gate, almost creating like what you would think of like a firewall between what you're doing and what is public outside of it. So that's what VPN is doing.
I can't find it right now, but I'll find it before the end of the day. Essentially, what I was going for is if you were to watch this network traffic, one of these many different, so these are all the different HTTP requests and responses going back and forth
From your
from my computer. When the moment I hit login, remember we have that, the request URL and the request method and things like that.
Oh yeah, you're making a post request there.
I am, yeah.
So the data is not being shown?
I know, because it's 302 and I can't get the request headers, don't have it on here.
And it doesn't have the data for the
I guess not. I'll find it in a second. But essentially what I'm trying to show off is if I'm supposed to be giving secure information like my birth date or anything like that, if it doesn't have HTTPS on the top, it's out in plain text. So like my goal was to show you my username and then my password is shown here in plain text. So you just want to make sure that whatever website you go to, especially if you're giving sensitive information, that that's HTTPS, but that S stands for secure rather than HTTP.
The other thing that I've seen is I haven't really looked into it, but the incognito for Google, what is that?
It just doesn't save cookies.
Oh.
And we'll get into cookies in a second. What's that?
No history.
No history, yeah.
Locally.
And to have this, like you have to sign for a server to have this, or you should create a coding that be able to address it.
Yeah, there's a way to set up your server, which is something that you won't do, like your bosses will do and teach you about. But yeah, there's a way to set it up so that it's no longer HTTP, but it's HTTPS, and that's set up on the server specifically. All right, let's continue on. So the second portion of a HTTP request is, so the first one is basically, where are you going? Like where's it going? Like I'm going to go inside of chase.com, the Chase Tower over there, and I'm going to go visit this 27th floor to visit this particular cubicle. Like this is where, like what kind of request is being made and where it's going, and then what protocol. Then we have something called headers. These are the things that are like really unspoken, but you need to know ahead of time, right? So it's kind of like, I mean, you can kind of think of this as nonverbal communication, the headers right here. So if I walk up to John, I got a big smile on my face, I say, good morning, how you doing today? He recognizes there's a nonverbal communication going on where it's like, oh, this person seems friendly, you know, and is outgoing and sticks out his hand. Like this is a sign of friendship, right? But if I were to walk up to John and I'm really cross on my face, and my face is all scrunched up, and my hands are real tight, I'm like, good morning, John. Like he knows that, oh, he might punch me or something like that, right? There's unspoken verbal cues, and like this is nonverbal communication. So you kind of deal with this on like a day-to-day basis. And similarly for inside of an HTTP request, there's unspoken communication, stuff that's not really terribly necessary. It's still necessary, but it's not like the main meat of things. The headers is kind of like, the headers is basically like the nonverbal communication part of like an exchange. What information am I going to get from just reading this request? What kind of information would you be reading just as a person is approaching you? These headers consist of the host name of like where am I actually sending this request to? Remember, this is just the URI. This is where am I sending the actual request to? And this user agent right here. This user agent is important because it tells you what kind of request is. Where is this request being made from, right? So it's kind of like if I didn't shower for many days or something, and I want to shake John's hand or something like that. There's a nonverbal communication saying like, oh, he probably smells really bad, and I might not want to shake his hand because it could be dirty, right? Similarly, inside, this is not a perfect analogy, but similarly inside of like an HTTP request, it's kind of like what is making this type of request? So there's Google Chrome 5234 is basically Google Chrome on your desktop. If you're making a request from iOS, there's a specific like it'll say like Safari like and some particular version. If you're making a lot of requests from Firefox or from Opera or something like that, it'll also say here as well. Can anyone guess of like why this particular section would be important? If you're like Amazon.com, right, and you're getting millions of requests over, and you can basically from all of your requests coming in, you can have some information revolving around like what kind of browsers are making it, right? So you can make some sort of guesses of like 50% of my customers are making requests from iOS, so I might want to beef up my iOS support, or they're mostly making it from Google Chrome or mostly from Safari.
I thought that was a question.
It was a question, but no one was answering, so I answered the question.
Oh, I wasn't my answer.
Okay.
Doesn't it depend on mobile versus full desktop site stuff too?
Yeah, it does. Yeah. So.
Yeah.
we
Okay. So it's raising my
had to be like,
Yeah, I didn't raise
I looked and then no one was like, I was like, all right, I guess I'll answer this question myself.
I can have a buzzer over there.
Also, everyone has been to those websites. We'll talk about more of this on Friday. But everyone has been to those websites where you visit on your phone and it's not mobile response. You have to scroll all the way across to click on this tiny link. You have to stretch it open in order to press that thing. The response that you get from the server, if they have a mobile responsive website, so it's saying like, if I send this, so when I go to Yelp.com on my phone, right? It'll say like, are you sure? Like, I see that you're making a request from your phone. Are you sure you don't want to open this up into the app? When you go on like Google Chrome, they won't do that because there's no Yelp app for online, like for a desktop. But the way that they can tell is from this user agent, when I'm sending that nonverbal communication over, saying like, I'm on an iOS device and I'm visiting you from like Safari or something like that. It's saying, oh, well, why don't you open this up with the app? We have a specific app for iOS. And this is how they tell like what percentage of their traffic comes from desktop and what percentage of your traffic comes from mobile. If 20% of your people come from mobile and 80% comes from desktop, you might want to prioritize desktop. Not to say that mobile is not important, because mobile is getting more and more big. But you like if you have data that shows 80% is coming from desktop, you might want to support desktop. Or if like when you start troubleshooting things, like we used to get these calls in all the time, like I can't see anything on my online loan account, like I can't connect. All right, when did you make this request? We were able to see when they made the request, what they sent over, and all that kind of stuff. Oh, this is my username and my unique identifier or something like that. So we'll look it up, and then it might say like Internet Explorer 1.0 from like the 1990 or something. Well, like we're gonna gather all the requests and responses from the last month from Internet Explorer 1.0, and it'll be like less than 1%. Sorry, we're not going to spend time on this. It just sucks. And that's kind of a harsh thing to say, but when a company has tens of millions of requests coming in every single day, I'm not going to focus on 10 people not being able to log in because they don't upgrade their stuff, or they don't have JavaScript enabled or something like that.
But how can you see that? Like, you say like, oh, this user from a website, this user from the voice or something like that. Like, do they have a software specific to be able to see that thing? Or
so when you go to like Google.com and you just press enter on like on your device, let's say it's a mobile phone, your device is basically saying my user agent is Google, is iOS whatever. Or when I make a request here on Google Chrome to Google.com, let's see, is there a request header somewhere? Request header, host, where is user agent right there. So it's basically saying this is the type of thing that is making, this is the type of device that's making the request over to this booking.leveloffice.com. It's using, I'm using a Macintosh, this particular operating system, I'm using Chrome, and there's a whole bunch of other stuff I don't really understand, but the concept is I'm sending a request and this is the type of device that's being used. And it automatically sends it based on whatever browser you're using. That's why these browsers take a long time to download and things like that. They're very, and that's why they use so much memory as well on your computer, because they're just such big applications.
so when the person who can see this one is a client and also is a server admin.
This one anyone can really see. This is a public, like when you make a request, they're all public. It's just whether or not the information is encrypted or not. So
The purpose of sending that is for the server side to see that and make a decision, if necessary, to change what needs to get sent back.
So what comes in next is like, so again, I start with, let's say I have an HTTP request. This is what a post request might look like. So I start off with the request line. The HTTP method is post, meaning I'm sending you some sort of information. Where am I sending to? Like, what's the URI? Like, what specific floor are you going to inside Chase Tower? What specific business are you going to once you're there? And then what protocol are you using? It's always going to be 1.1 for us. Inside the headers, it's like like, where are you going? I'm going to the Chase Tower. Like, I'm going to google.com, amazon.com. Who is making this request? Oh, it's Google Chrome 5234, Google Chrome version 52 patch number 34. And then what are you sending over? Like, I'm sending over a application. Like, I filled out one of the forms on your website, and it's going to be an encoded form. You know, there's going to be other types where I'm just sending over pure HTML, or I'm just sending plain text or something like that. There's many different content types. Followed by a blank line. There's always going to be a blank line here. And then finally, we have this optional body. Sometimes you might send over something inside of a body saying, like, this is the information that I'm sending over. So I have, like, query equals new Jordans in red. This might be something if I'm shopping on, like, Zappos.com, and I'm saying, like, I'm sending a request over to you, a post request. I'm changing something. I want you to give me something revolving around new Jordans that are red.
So that's the search, like that's what you're typing into the search bar in Zappos, or
So
that's saying like add to cart.
That is, here, let me show it. So if I go to, like, Amazon.com or something like that, right? And I make a request here for military backpacks, right? And I hit enter. I am asking them to basically, so when I fill in that form right there, basically I'm making a post request saying, like, I'm sending you data, and then the data that I'm sending over is military backpacks. There's probably a whole bunch of other things going on here behind the scenes, but it's basically I'm querying their database in all of their, like, different categories for military backpacks specifically. So that optional body that I'm sending over is basically saying I'm looking for military backpacks, and then as a result, they will see my request coming over. They will, like, query their database for that stuff and then return that back to me. And if you can kind of look all the way up here, it's hard to see. It's hard to see, but you can kind of see they've acknowledged it by sending all this stuff back right here. Anything after a question mark is basically called a query string. It's basically if I wanted to revisit this website for this particular, like, query that I've asked for, like military backpacks, I can just copy this and then send it back. I don't have to make a post request. I can just make a GET request. This is where it specifically lives. And then this is kind of like what we saw. So you can send either a post request over, like we did with that, like, show me all this stuff, and I'm sending you information. I'm going to ask you to create something new specific for me. When we did stuff with, like, military backpacks, that would probably go inside of here, like query equals military plus backpack or something like that. Or you can make a request the same way using the query string inside of a GET. So again, the first line is the request with the HTTP verb, followed by where everything lives, like the URI, and then the HTTP protocol. So this one particularly, if you ever wanted to, like, really break down HTTP, like URL strings, so it is /search, and again, everything after the question mark is a specific query for their database. The query is going to equal, like, air space Jordans. This %20 is space, and the color is also going to equal red. So if you wanted like a specific query, this is what you would send over. Some more detail about request headers that are going to be sent over. So request headers is this nonverbal communication that you need to send over, that you inherently, your browser is going to just send over with every single request that you make. There's things like which domain does it live at? So it's like google.com, ebay.com, or something like that. The accept language is an interesting one. Accept language will take in a two-letter code, which will say, like, I'm sending a request, and I'm only going to accept responses in Spanish or in Japanese or in English or something like that. This is also based on where you are in the world. So if you're going to google.com, inside of like Taiwan or something like that, the thing that you get back will probably be in Chinese. Or if you want to specifically accept English and Spanish on the way back, for it's like, hey, this page is in English, but it can be translated to Spanish. That is something that's also available. User agent is what's being sent over, and then accept, like, what am I willing to accept back from you? Is it going to be text HTML, like HTML text coming back, or is it just going to be just plain text? Is it going to be an image? Is it going to be a CSS style sheet? What's it going to be that I'm going to get back? So we sent over a request, and we're getting a response back from them. So I sent the request over. It looks a little something like this. I can never get that to it. Like this. And then the server hears me and sends a request back, a response back. I have many different things again. The first one is the status line. It has first the status code, like the 200 or 300, 404 things that we've kind of seen before. The reason phrase, which is basically the human readable version of it, and then the HTTP version. Again, everything is 1.1. You're going to need to know the HTTP status codes like off the cuff. So the way I think about it is, let's say you're at a bar, and you meet somebody that you find is attractive at the bar, and you say, "Do you want to go out with me?" A 200 status code is yes, everything is good. Like, say, I would love to go on a date with you, right? That is something that is going to happen. It's something that's going to happen. It was okay. So if I go to google.com and it comes back as a 200, it means I've received your request and everything is good. I'm sending you a response back. 200 is good. 300, on the other hand, is basically a redirect. So it's saying, I acknowledge that you sent me something, but I'm going to direct you somewhere else. This is basically saying, hey, I find you attractive to the person at the bar. Would you like to go out on a date? They acknowledge that you're there, but they say, let me introduce you to my friend, right? That's a redirect from one place to another.
So basically, if the company, the host or whatever, just change their website URL, is that what we're talking about?
Yeah. So it's kind of like if it used to live here, but now it lives somewhere else, that's called a redirect. Or like, let's say you have a GitHub repository that you named one thing, and then you decided like, oh, this budget is too small. Maybe I want to name it as like Budget Active Record Challenge or something like that. If I change that name, it'll redirect me whenever I visit the original. Or when you go to google.com, it actually just redirects you to https www.google.com.
It's kind of interesting that a website or the server would know what you're looking for. So if you type in like Jimmy's Steaks or something like that, and Jimmy's Steaks changed to Jimmy's Beef House or something.
Yeah.
You would actually know to find that different than you upgrade your website.
Yeah, if you set it up that way, yes. So it's basically like when people go to, it's kind of like you cannot go to like your bank account without logging in, right? Like you can't go to like, let's say you visit chase.com and you log into your account, right? And you bookmark that page. When you bookmark that page, you think, oh, maybe later down the road, if I just click the same link, then I'll be able to get in. It'll actually redirect you at that point, saying like, hey, you're not actually logged in. You can't log in. You can't visit this page quite yet. So that would be a redirect as well. Redirects are very common. So again, 200 is you go up to the person at the bar and you say, hey, would you like to go on a date? Yes, I'd love to go on a date with you. Everything is good. 300, like anything starting with a 3 in the front, basically says, I hear you. Let me introduce you to my friend. Let me redirect you somewhere else. 400, and we've seen like 404 not found, is basically no. Do you want to go on a date with me? No. Something went wrong. Like try again later or something like that. Maybe you smell or something like that, or maybe you are dressed inappropriately for this particular bar or something like that. I'm just not interested right now. Try again later. It's just but the answer is still no. Anything with a 400 in the front is no. And then the 500 is an internal server error. 500 meaning like something is, I acknowledge that you sent me a request, but something's wrong with me. It's not you, it's me. Or like, I'm sorry I had bad sushi last night and I'm just not feeling well or something like that. I can't go on a date with you, but there's something wrong with me and not you. Don't worry about it. So again, 200, yes. 300, let me introduce you to my friend. 400, no. 500, irritable bowel syndrome or something. Or like food poisoning. Those are the status codes that are going to come back on every single request. 200, yes. 300, redirect. 400, no. 500, internal server. There are hundreds of different status codes, and you can kind of find them at your leisure. I'll send this out in a little bit. Status code dogs. There's entire websites for different status codes. I can kind of go through a few. Like 200 is okay. No, I can't actually scroll through. Like 201 is created. 202 is accepted. Like there's no way to really memorize all of these things, but they all share a certain. They all share like the first number. As long as it starts with a 2, it's a 200 level status code. It's good to go. When we get to something like 404. Not found or something like that, a 400 level status code is just, the answer is no, like you did something wrong for some reason. And then there's 2 pictures going along with it. There's also an interesting HTTP status code called I am a teapot. It literally is, I don't know why they decided to do this, but there is a error code called 418 called I am a teapot. That is the reason phrase that's coming back. I'm sure there's some sort of humorous thing in the background of why that is, but it's still a 400, something went wrong.
Is there a number that's supposed to show up on the link? Like on the
No, the response coming back will come back inside of the response headers. You can kind of see it right here. So I get a response headers somewhere on here. Right there. It's a 302 found. So it redirected me. I know that this was a redirect. So again, the first thing that comes back is that status line with the status code, the reason phrase, and the version. Status codes we all know, 2, 3, 4, 500. Pretty simple. 200, yes. 300, let me introduce you to my friend. 404, no. 500 is bad sushi. And also when you get a response coming back, it's kind of like going back to that bar example. When that person acknowledges your response and gives you some sort of response, there's some nonverbal communication that's also happening. There is like, okay. Okay is a 200 level status code because they agreed, but it's not an enthusiastic greeting, right? Rather than saying like, yes, I'd love to go, I've been eyeing you as well, is a 200 level status code, but it's like a more enthusiastic status code coming back. Similarly, when we deal with response headers, there's things that they're also sending back. So things like, what am I sending back? What kind of content am I sending back? I'm sending back HTML. How long is the thing I'm sending back? Is it 5 letters long, or is it 492 letters long? How long is the response I'm sending back to you? Am I going to need to set a cookie of some sort? So it's like, hey, remember that I've been logged in for 2 weeks? That is something that the server sends back to you as a cookie, saying like, so that when you make a further request, you never have to like sign in again. And then finally, like, what date was it sent? So these are some of the response headers that will come back. These will definitely show up on all of them. And again, the web is just made up a bunch of different HTTP requests and responses. So when I send a request out to like Google, like Amazon.com, right? Just when I saw one a little bit earlier, there are many things happening over here. There's this link that's coming back. There's this entire header section that's coming back. There are different pictures for different items. There are many different links with checkboxes on the left-hand side. These are all specific links, and these were all sent back as one response. So it's kind of like in the background, when you just type in military backpacks on Amazon and you just hit enter, there's actually on Amazon's side, they might have to do 50 to 100 calls just to get all of these pictures on here. And if you want like a bestseller or something like that, that's another request that they have to make, saying like, show me all the military backpacks, but make sure that you tell me which ones are the bestseller so I can show it up on this page as well. So in this one page alone, there's probably upwards of 500. You know, I'm spitballing here, but 500 requests going on in the background to get all this stuff out on the page. That's how many conversations, HTTP conversations, are happening per page.
And so just like with the database, it's just looking for that particular column in the table.
Yeah, yeah.
Military backpack.
Yeah, like show me 50 military backpacks, and maybe it's like the first page of your Amazon search history, like when you type in military backpacks, probably has the best stuff on there, right? So they might say like, show me 50 backpacks that are all highly rated and all have like lots of people buying it and great reviews and things of that nature, rather than just showing, give me 50 random ones. I think we have this last slide here. It's important to know that the web is stateless. And what that means is that every single time that I make a request, it's like the first time I've ever made that request. So it's kind of like 50 First Dates with Adam Sandler and Drew Barrymore. Like even the character had amnesia, so was not able to remember that, you know, they had been on many different dates before. So they went on 50 first dates. You can kind of think of you and your browser and, you know, your browser to like google.com as every single time that they talk is like a new time that they talk. It's stateless. It doesn't remember anything that you've done in the past. Yeah, got it. So the concept of if everything is stateless, meaning like every single request that I make is a brand new request, how does it know that I've logged in before? How does it know what I liked in the past? How does it know what my search history was, or like when it says like welcome Jonathan at the top of my Amazon.com page? How does it know all of that kind of stuff? That sort of material comes from cookies. A few slides earlier, it's the server will send you back something called set cookie, which means like, hey, whenever the browser is going to memorize certain things about what you've done, and so that when you make further requests, it knows that, hey, the currency is US dollar, so I'm going to send that as part of the request over to Amazon.com. So again, the web is completely stateless, meaning that every single time that you make a request is like the first time. But it uses cookies to basically keep track of like all the stuff that you've already done. And a good way to see this in action is if I go to, what's a website I never really go to? Walmart.com. Walmart.com is secure HTTPS. That's good. You always want to make sure that you get that. So on this page, again, like I said, there are thousands of requests being made for this one. Like there was a specific request to get this G on the page, a specific request to get this this big help for any room on the page, and this pre-order is a different link, and then these are all different links and things of that nature. So there's just hundreds, if not thousands, of requests happening on this page. Now, if you take a look, my cart has absolutely nothing inside of it. So maybe we will look for Halloween candy. So again, I'm making a request from my client to Walmart.com for Halloween candy. And if we take a look up top, if I ever want like to make just a GET request to just get this data back, all I have to do is just copy this, and this is a GET request. I'm not posting anything. There's no form here because this is in a way just a form that I'm filling out. I want Halloween candy, search. I'm posting. I'm giving you information so that you can give me back information. Let's say I want this this Mars chocolate right here. I'm going to add it to the cart. Remember that every single request that I send over is stateless, meaning that every single time I talk to Walmart.com, it's like the first time I've ever talked to Walmart.com. So when I click this link right here and I go to just back to Walmart.com, that's a brand new thing. It's never seen me before. It doesn't have any recollection that my information from my cart is here. So I click Walmart.com. It's a brand new request, and yet there's an item in my cart, and there's that Mars candy that we were talking about earlier. How does it know that if the web is stateless? And that's through the thing of cookies. The cookies will basically say, like, this is what was in your cart. So when I send a request, it puts those cookies inside of the request and says, like, hey, remember that there's stuff inside the cart.
That's the same thing too. Like if you have multiple windows open from Walmart or Amazon, and you close the most recent one, you can go back to the other one, refresh it, and it's already
Exactly, yeah, because it saves the cookies in your browser, meaning your Google Chrome.
in the computer.
Yeah. Yes.
File.
Yeah, it's all stored locally, right? So when you say, like, save me on this computer for 2 weeks so I don't have to log in ever again, it's saved on this specific computer. If you go to a public library, it won't have that because it's not in your cookies right here. And when you clear your cookies for any given reason, you might need to sign in again because it doesn't know that you're logged in.
When you come back, you log out, you shut down, you come back and log in again. How does it suggest the cookies? Like, I mean, not for different types of candy too, because like it tends to develop starts to understand what you're searching for after a while, right? Mm-hmm. So, is that within your profile? That's within your profile, right? Not within the cookies. I'm asking.
Yeah. So I think those are two kind of different things. So there's entire companies whose sole mission is to gather data about you to get curated products and send it back to you.
Right.
So that I don't think is technically related around cookies. So I went to visit a company called Ibotta in Denver a couple weeks back. It basically says, like, we want to be the front row of the internet, the front page of the internet, so that before you go shopping on Walmart.com, you go through our portal. So what happens is, like, let's say I buy 20 bags of Halloween candy from Walmart. They can gather that data from me, and then this is where, like, big data is happening in, like, the real world now. It's gathering all the information they can about you to, like, basically create a bunch of data, customized shopping lists so they can sell you their product and sell you their...
So you open up Google Chrome and, like, that's the first thing is a bunch of potential websites for you to branch out to?
It's not technical. It's kind of like that. So it's like when I go to Amazon.com, it's like, hey, based on your recent search history, blah, you might want to do this. Or it's like if you go on, like, when we were working at Groupon, it was based on the Groupon deals you buy, there's certain data that we can infer about you. And then there were entire teams of people saying, like, let's analyze this data to see what we can predict what they have next. What kind of deals can we show on the front page so that they will be more keen to buying those things rather than searching through endless pages. So that's the answer to your question is it's a bunch of big data. Like there's companies that are dedicated to reading the data, all the HTTP requests that you make and all the responses that they send back. They read all of that information. There's like trillions of like requests and stuff like that. It's like, how do I organize that in such a way so I can curate like some products for you, but that does not have anything to do with cookies specifically.
Okay, so it's attributed to your profile.
It does. It is attributed to your profile. Yes.
So like if I logged into another machine, I would still get that same response without like curating.
Exactly.
Content.
Yeah. Mm-hmm. That's precisely right.
For this cookie thing, let's say if you click like submit it,
mm-hmm.
is a cookie is gonna be stay in your local drive or it's gonna clear?
Your cookies will stay on your browser, on your machine for X amount of time before it gets deleted. I don't know how long that X amount of time is.
Because when you click like submit it, so basically, well, that like number 2 is gonna be gone, right? For example,
if I order this, then the cookies will, when I send the request over, it's like, hey, this person's bought everything inside their cart. I'm going to send cookies back saying like there's nothing in the cart now. And another thing to remember is that cookies are browser specific. So if I go to walmart.com and incognito, walmart.com, it's the same Google Chrome, but one has items in the cart and the other one does not. If I go to Firefox, again, it's the same concept where it's only specific to that particular browser. Okay. So a little bit like basically a summary of cookies. One, you make a you make a request to a server for something, and then the server will give you a response. Remember, it's a request and response cycle. That's all the web is. It's just a series of I make a request to you, you give me a response of some sort. The server is going to set, like, basically tell your browser to set some cookies. And then every subsequent request that you make afterwards is going to have those cookies inside of there, so that you don't have to log in every single day. You only have to log in once every 2 weeks. The client stores the cookies, meaning your machine stores all your cookies. The server doesn't store anything. It just tells you what to memorize, and then every single subsequent request, it'll have that in there. But yeah, and that's basically a really down and dirty like intro to HTTP. HTTP stands for Hypertext Transfer Protocol. It's basically how do I send stuff back and forth over the internet. Like there's a protocol that I have to follow. So there's a request and response cycle. There's a request has to be built in a certain way, and a response has to be given in a certain way so that there's consistency. It's kind of like when I dial a phone number in the US, I know there's a protocol for that. There's always going to be a 3-digit area code, then a 3-digit other thing, and then the 4 digits. Any questions on anything?